Alright, so today we are going to continue on our discussion of matter. We have talked about the classification of matter and how we divide it up into the different categories, and we have talked about the properties and changes in matter. Now I'm going to talk about a specific type of physical properties. Physical properties can be divided into either two categories. Remember, physical properties are properties that describe how what a substance is. They describe the substance, like color and size and shape and mass and stuff like that. They describe the substance. So a physical property is what we're going to be talking about today, specifically two different types of physical properties. So that is what today's notes are all about. Intensive and extensive physical properties. So again, review. Physical properties are characteristics that describe the physical nature of a substance, and they can be measured or observed with our senses. We can measure them using tools, which uses our senses, or just observe them, like looking at something and seeing its color. So there are two types of physical properties. They are intensive physical properties and extensive physical properties. So intensive, in, and extensive, X. That'll be a helpful way to help remembering the definitions. So let's move on. Extensive properties. Extent, extensive, exit, outside. All right. So an extensive physical property is a physical property that depends on the amount of substance you have, or the extent. Extensive. All right. So what I mean by that is how much you have. If I have a little bit of something, then I can describe it like I measure this, I can figure out its mass. If I take some of that out, if I remove some of the crystals from this container, then it will have a different mass. If I remove how much I have or change how much I have, the mass will change. So that means length, mass, and volume, all things that require a numerical measurement, are all going to give you an extensive property. If I have length, how long a piece of wood is, if I have a log that has a length, well, if I break that log up or cut it up and I get rid of some of it and I now have less, if I have less log, I now have a shorter length. The length depends on how much I have. If I change how much I have, then it's going to change the length. Same thing with mass. If I change how much of the log I have, I'm going to change its mass. Volume. If I add more water to a container, I have a larger volume of water. Volume. So you can think of extensive properties as things that have numbers attached to them. Like length, like 36 centimeters. Mass, 58 grams. Volume, 600 milliliters. If I have a number attached to the property, then it is an extensive physical property. Intensive physical properties are physical properties that do not depend on the amount of substance you have. All right. So, example of that, color. My shirt is blue. If I were to take this shirt and rip it in half and get rid of half of it, I have less shirt. The shirt is still blue. All right. So making less does not mean the color has changed. Now, some people might be tempted to think, like, if I were to add water to this, the more water I add to this mixture, the lighter blue this is going to change. All right. So as I dilute this, it's going to get lighter. You guys have all seen that. If you say you have a little bit of chocolate milk, or add a little bit of chocolate to the milk, it's a very slight brown. You add more chocolate, then it's a darker brown. And so adding more made it darker brown, but you're not changing the color, you're changing the intensity of the color. The color is still brown, right? Whether it was a light brown or a dark brown, you're not changing its actual color, you're changing the intensity of that color because of how much you have, but the color itself is not changing. So the physical property of the color is intensive. It does not matter how much of a substance I have. It doesn't matter how much of this copper chloride I have. This copper chloride is this greenish blue color. That's what color it is. It will always be that color if it's copper chloride, no matter how much I have. Shape. You can have a big shape, little shape. I mean, if I like a piece of paper, for example, it's a rectangle. If I then change the shape and crush it down, I still have the same amount of paper. It's still the same mass, So its shape is not part of its how much it is. All right, now I can change the shape by changing how much I have, but just changing the shape doesn't necessarily change how much I have. Like if I change the mass of something, I have to change how much it has. So mass is an extensive property. Shape is an intensive property. Melting or boiling point. Now melting point is the temperature at which a substance will go from solid to liquid. Boiling point is the temperature at which a substance will change from a liquid to a gas. Those are the definitions of melting or boiling point. So these are intensive physical properties. Think about it if you have a pot of water. It doesn't matter whether I have a small pot of, like, say, 100 milliliters, or whether I have a large pot having 3 liters of water. Either one will start to boil at 100 degrees Celsius. That's the boiling point of water. Water will boil at 100 degrees Celsius, whether I have a little bit or a lot. The amount I have doesn't matter. Now, the amount does affect how fast. If a little bit of water will boil faster because it reaches that temperature faster. But it's not changing the temperature. It still boils at 100 degrees Celsius. When it reaches 100 degrees Celsius, it will boil. No matter whether I have a teaspoon or a lake of water, it doesn't matter how much water I have. The boiling point of water is 100 degrees Celsius. So a very, very important physical property that we're going to talk about a lot, and you're actually going to be doing a lab with it later this week, is density. Density is defined as the ratio of the mass of a substance to its volume. We talked about density a little bit in an earlier lesson, but we're going to get into it a little bit more now. So the mass of a substance to its volume, it's a ratio. A ratio means a fraction, right? So that ratio is constant for a substance. So density is an intensive property. We can say water has a density of 1 gram per milliliter. We know that whether we have a lake of water, an ocean of water, or just a teaspoon or a tablespoon of water, water has a density of 1 gram per milliliter. It has that volume. On a mass versus volume graph, density is always going to be the slope of that line. So mass versus volume would be, I have mass on my y-axis, volume on my x-axis, and the slope of my line, my rise over run, is my mass over my volume, my slope of the line. And it will always be a straight line, which means it's constant. So the mathematical formula for density, which we learned the other day, is density equals mass divided by volume. D equals N divided by V. Now the unit for density is grams per milliliter if we're talking about liquids, because we measure the volume of liquids in milliliters, and grams per cubic centimeter for solids, because a cubic centimeter is the unit for a solid. Alright, so now what we're going to do is I'm going to go through a couple of examples of density problems. I've done a few examples of density problems for you already in a previous lesson. I'm going to do some more. So we have these 3 examples that should be on your notes, and you can write out or type out the solution to these as I go in the examples. Alright, so we're going to do our density example. The first one from your notes says a sample of a substance has a mass of 45 grams. So I have my mass is 45 grams and a volume of 12 milliliters. So the volume is 12 milliliters. What is the density? Alright, well, density equals mass divided by volume. So I'm going to find my density by simply plugging in my mass, 45 grams, and dividing by my volume of 12 milliliters. So I'm going to take my calculator and I'm going to do 45 divided by 12, and if you don't have a calculator you can use your phone. There's one on your Chromebook also, or your computer. So that gives me a density of 3.75 grams per milliliter. I want you to always leave it in 2 decimal places unless I tell you otherwise. So your density here is 3.75 grams per milliliter, And that is a simple, easy first example. All right, so example 2 in your notes says a sample of a substance has a density of 4.5 grams per milliliter. So I have a density of 4.5 grams per milliliter and a volume of 8.0 milliliters. What is the substance's mass? All right, so I'm going to still start with my first equation of density equals mass divided by volume. You'll notice that each one of these I'm writing it a slightly different way because I want you to see all the different ways that this can be written and still be mathematically correct. So your density equals your mass divided by your volume. So before I plug in numbers, I want to actually solve this. So I want to get mass by itself. So I'm going to multiply by volume over here. So now I have divided by volume and multiplied by volume. Multiplying and dividing are opposites, so those will cancel each other out. And if I do it to the left or right side of the equation, I have to do it to the left side of the equation. So then I end up with density times volume equals mass. And that's what I want. I want something to equal mass because I want mass equals something. So now I'm going to plug in my numbers, and I have 4.5 grams per milliliter times 8.0 milliliters equals my mass. Okay, so now you'll see that your milliliters are being divided and being multiplied, so your milliliters are going to cancel. So now I have to do my calculator. 4.5 times 8, and that gives me an answer of 36. Now I did say that I always want you to round to 2 decimal places, but if it comes out to be an exact number like this, don't worry about that. So 36 what? You can't just give me 36. We have to have a unit. So 36 grams. All right? 36 grams is our final answer. So that is how you would solve for the mass on a density problem. Okay, so now we're going to do example number 3. Let me focus that a little bit. Example number 3, a sample of a substance has a mass of 145 grams. So now I have my mass equals 145 grams and a density of 56 grams per milliliter. So density equals 56 grams per milliliter. This time I want to know what is the volume. All right, this is the slightly more complicated one. So we're going to do density equals mass divided by volume. And just like we did before, we don't want volume to be in the denominator. If I'm trying to solve for volume, I want it to say volume equals. I don't want to solve for volume in the denominator. So I'm going to multiply both sides by volume so that my volumes cancel out. And now I have volume times density equals mass, but I want volume equals. So now I have to move my density. So I'm going to divide both sides by density, and the densities cancel out, and so I'm left with volume equals mass divided by density. So now I can plug in my numbers. I have 145 grams divided by 56 grams per milliliter, and the grams are going to cancel out and you'll be left with milliliters. So then I put in my calculator, 145 divided by 56, and my calculator gives me an answer of 2.5892855714. I want to round that to 2 decimal places, so 2.589. That 9 is going to make that 8 round up, so it's going to be 2.59 milliliters is the unit that's left, and that is my volume, and that is my final answer. So hopefully after doing those 3 examples and the 3 examples in the previous lesson about density calculations, you will understand how to do a Alright, now that you've seen the examples of how to work out density problems, just remember density is an intensive physical property. I do want to point out something that I forgot to mention earlier and that I want to make sure you understand. Intensive and extensive properties are physical properties. So when you're classifying things as whether they're intensive or extensive, if you're dealing with something that's a chemical property, chemical properties are just chemical properties. They're not intensive or extensive. So if you have a list of properties and I ask you to tell me whether it's intensive or extensive, if it's a chemical property, the answer is chemical. It's not an intensive property, it's not an extensive property, it's a chemical property. Intensive and extensive are physical property categories. So if something is a physical property, it's either going to be intensive or extensive. If something is a chemical property, it's just a chemical. It's very important that you understand that, so I want to make sure that you think about that. So iron combines with oxygen to form rust is a chemical property of iron, is how it reacts. It doesn't matter how much iron I have. It doesn't really matter that, but we're not going to talk, we don't call it as intensive or extensive. They're just chemical properties. All right. Intensive and extensive are only for physical properties. So first thing you need to always do before you determine whether it's intensive or extensive is ask yourself, is it a physical property or a chemical property? If it's a chemical property, then your answer is just chemical property. If it's a physical property, then you have to determine whether it's intensive or extensive based off of whether or not the amount matters. So now you can go on and do your assignments.